All right. So we were last class, which was almost a week back. So we were discussing various forms of equation of straight line. So this question I'll do, which is an important question before we proceed to the other forms of equations of straight lines. So A 10, 4, B -4, 9, and C -2, -1 are the vertices of a triangle. Now find the equations of first one, AB, the line AB. Second one, the median through A. Third one, the altitude through B. And the last one, the perpendicular bisector of side AB. So can you tell me, like, which is the first one, equation of AB? How will you find?
Points of form.
A and B, there are 2 points given. Slope is not given. Of course, you can find slope and do point slope form, but directly you can write 2-point form, isn't it? What is the 2-point form? What is the 2-point form?
Y minus
Y1 is equal to
y2 minus y1 by x2 minus x1 into
Hmm.
x minus x1.
Okay. So here A is 10, 4, B is -4, 9. So treat this as x1, y1, this as x2, y2. So we have y minus 4, y minus y1, it's y2, 9 minus 4 by x2 minus 4 minus 10 times x minus 10. Okay. So we have y minus 4 is 5 upon minus 5 upon 14. So multiply throughout by 14, 14y minus 56. 14 into 4 is 56. Then minus 5x plus 50. So we get 5x plus 14y is equal to 106. So this is the equation. 5x plus 14y is equal to 106, or minus 106 is equal to 0. Next. Clear? Next. Now you tell me, how do we find the altitude through A? So let's say this is A. What is the point A? 10, 4. Don't see it, geometrically correct. It may not be the proper, if you draw on a graph plane, it may not be correct, but just roughly drawing it. So actually B will be up. So you don't worry about all those things. If we have to draw it accurately, this will be a mistaken triangle. Okay. So now this is a triangle. Now, first we have found AB line. Now he's asking the median through A. So what is a median through A? Can you explain?
Line passing through
I'm not able to hear.
Line passing through it.
And what is a median? How is a median defined?
Six BC in two equal parts.
Yes. Yes. So two equal parts means, how will you find? How can you find? To find the equation of a line, we need two conditions. One condition is that it passes through A. Now, second condition,
Point of BC.
very good, passes through the midpoint of BC. So let this midpoint of BC be D. Okay. Let D be the midpoint of BC. So what are the coordinates of D? You see, x1 minus x2 by 2. So minus 4 minus 2 upon 2. Then 9 y1 plus y2 by 2. So 9 minus 1 by 2. So minus 6 upon 2 is minus 3. 9 minus 1, 8 upon 2 is 4. Okay. So minus 3 comma 4 is the value. And A we already know it is 10 comma 4. A is 10 comma 4. So therefore the equation of median AD, you will see that both y coordinates are 4. So it will be y equal to 4. You don't have to do anything else. But still, if you want to do the midpoint form, the 2-point form, y minus y1 by y2 minus y1 by x2 minus x1 into x minus x1. So we get the right hand side as 0. So we get y minus 4 equal to 0. So this is the median through the median.
Passing through A.
Right. Got it? So what did we do? We three vertices are known, so we can find the midpoints of the sides, midpoint of the side and the opposite vertex. The line joining that will give us the median. Okay. Next. Third one, the altitude through B. What is an altitude?
Line passing through B
Hmm. And
and midpoint of
no,
AP. No.
no. Midpoint means it will be median. It will not be altitude. How do you define an altitude?
I don't know.
Think. You have done half base into height calculations.
Yes.
Hmm. So how do you find the height? It is a line passing through B and perpendicular to AC.
AC.
That is the altitude. Altitude through B. Okay. So how will you find the altitude through B? Now you explain. We need two conditions. One condition, it is passing through B. What is the second condition you can find?
Not getting.
Hmm. B, now let us call this as this point as BE. Now, BE is perpendicular to AC, correct?
Yes.
Can we find slope of AC?
Yes.
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 Hmm. Then BE, slope of BE and slope of AC, what will be the relation?
Slope of B, E and AC.
Hmm. Slope of BE and slope of AC. What will be the relation?
Not perpendicular.
They are perpendicular. So for perpendicular lines, what is the condition on the slopes?
Product of their slopes is equal to -1.
Very good. So first we find slope of AC. From there, we can find the slope of BE, and then we find the slope of BE and it passes through B. So what will we use? Which equation? Point slope form. We'll use point slope form. Okay. So first step is slope of AC. Slope of side AC. So A is 10,4 and C is -2, -1. So slope of AC is y1, oh, y2 minus y1, y2 minus y1, right? X2 minus x1, y2 minus y1 by x2 minus x1. So we get -5 upon -12, that is +5 upon 12. Now, the altitude, let the slope of altitude BE be M2. Now, since BE is perpendicular to AC, since both are perpendicular, M1, M2 is equal to -1. Therefore, M2 will be -1 upon M1. That is -1 upon 5 upon 12. So this is -12 upon
12.
5. Now, what is the coordinate B? -4, 9. So equation, the line BE, right? The altitude through BE, altitude through B, passes through B. -4, 9. Altitude through B passes through -4, 9. Therefore, the equation of BE, the altitude, is y minus y1 is equal to, right, I'll write like this. Y minus y1 is equal to m2 into x minus x1. Point slope form. So we get y minus 9 is equal to -12 upon 5 into x plus 4. X plus 4. So 5y minus 45 minus 12x minus 48. So bringing all to the left hand side, 12x plus 5y plus 3 equal to 0. So this is the equation of the altitude. So did you understand how we did? This problem is a very conceptual one. So BE is perpendicular to AC. So we find the slope of AC. Then from there we find the slope of BE using M1, M2 equal to -1. Then slope of BE and the point B. We apply the point slope form and we get the equation. Clear? Have you written now?
Yes, 1 minute. Yes, completed.
Okay. Next, the fourth one. the perpendicular bisector of side AB. What is a perpendicular bisector?
It is perpendicular to AB and bisects AB.
So it passes through the midpoint of AB and it passes through the midpoint of AB and it will be perpendicular to
AB.
AB. Perpendicular bisector of AB. So what do we have to find? Tell me, how will you find this? We need two conditions to find the equation of this perpendicular bisector. No? Think. If you have done the previous question, then this question will be easy.
We just did that M1, M2 is equal to -1.
Yes. So what will be M1?
M1 will be AB.
Slope of AB.
Yes. Slope of
M2 will be
slope of this line.
slope of the perpendicular bisector. Okay. So from there we find M2, the slope of the perpendicular bisector. Then which point does it pass through?
Midpoint it is passing through.
Yes, very good. So So the perpendicular bisector of AB, side AB is, you know, it passes through the midpoint F of AB and is perpendicular to so two conditions. So, so A, we'll write here, is 10,4. B is -4,9. 10,4 and -4,9. So now slope of AB, or first we can find the midpoint of AB. The midpoint of AB x1 plus x2 by 2, y1 plus y2 upon 2. So 10 minus 4 is 6 upon 2 is 3.
13 by 2.
Hmm?
13 by 2.
Next is 13 by 2. Now slope of side AB. M1. So y2 minus y1, 9 minus 4 by minus 4 minus 10. So we get 5 upon minus 14. Minus 5 upon 14. So if slope of the perpendicular bisector is M2, then M1, M2 is equal to minus 1, which implies M2 is minus 1 upon M1, which will be 14 upon 5.
5.
Therefore, the equation of the perpendicular bisector is y minus 13 by 2, because it must pass through F. Slope 14 upon 5 x minus 3. So let us multiply 5. Okay. We'll have to multiply with 5 and also with 2. So we have to throughout multiply by 10. Throughout LCM of 2. So we get 10y minus 13 into 5, 65. Okay, I multiplied by 10. So when I multiply this by 10 here, 5 twos. So 10, so 14 into 2, 28. So I get 28x minus 28 into 3. 28x. So minus 8 3 is 24.
84.
Hmm?
84.
Okay. Okay. So bring 10 to this side. So 28x minus 10y. I'm always keeping coefficient of x as positive. 28x minus 10y. You add this minus 84. So 65, 75, 85. So minus 19. It's minus 19. So there's the correct answer. This problem is a very important problem. Whatever we have done in the last, these are very basic, fundamental in one sense, but we need to get a full grip. We should not make any mistake in this one. Okay.
Yes.
Now next, we'll move on to, so why is it not coming? Next page, again, other three forms. Other three forms of the straight line. So three more important forms of straight line. These are little trickier. The first four forms were quite straightforward. Um, Point slope form, 2-point form, slope intercept form, and the double intercept form. Now, this one, uh, this is form number 5. This is the normal form, or the perpendicular form. Normal form or perpendicular form. Okay. Now, this is a very important form to understand. So the equation of the line equation of the straight line whose distance from the origin is p, small p, and the normal drawn from the origin onto it onto the line makes an angle alpha with the positive x-axis. Makes an angle alpha with the positive x-axis in a counterclockwise sense. Is x cos alpha plus y sin alpha is equal to p. Very important to remember. You should maintain one list of formulae, or if that is difficult, take a highlighter and in your intermediate textbook, highlight all the important results. And we can make a separate formula. Just you don't have to write all this. You just have to write normal form, perpendicular form, x cos alpha plus y sin alpha equal to P. Hmm? And like all the seven or eight types of equations of straight line, we should note down thoroughly. There are so many formulae. Mathematics and intermediate, it will have, hundreds of formulae which we have to memorize. So this is the straight line. This is the straight line. Uh, whose distance from the origin is P, and the normal makes an angle. Let us do that. This is the normal. It's perpendicular. Now this is the origin O, and let P be the perpendicular. Okay, and the distance OP is P units, and the angle made by this normal with the x-axis is alpha. So I'm showing the proof. Let the line be as shown. In the figure. All right. So let OP be the normal or perpendicular from O origin onto the line given OP is equal to small p. Also given now this angle uh, angle that OP makes with the x-axis is alpha. Okay. So now I want to find the coordinates of this point P. Let this point be Q. Okay. That means we have drawn another perpendicular from P onto the x-axis. So let PQ be perpendicular from P onto the x-axis. So now in triangle, therefore, from triangle OPQ, sine alpha is PQ upon OP. So this is PQ upon small p, which implies PQ length is P sine alpha. Okay. Now cos alpha, this is sine alpha is opposite side by hypotenuse. Cos alpha is adjacent side by hypotenuse. So OQ by P. So OQ is P cos alpha. So now you see here OQ is the x coordinate of P and PQ is the y coordinate of P. I'll write this XP, YP, write the coordinates of P. All right. So therefore the coordinates of P are OQ length and PQ length. See, OQ length, PQ length. That will be the coordinates of P. So OQ is P cos alpha and PQ is P sine alpha. So these are the coordinates of P. So we found P now. Now we want to find, so we found P. Now we also have to find the slope of this line. Now this line is perpendicular to OP. So the slope of OP is equal to M is equal to MOP slope is equal to tan alpha, because slope of OP is tan of the inclination. Tan of the inclination. So slope of OP is this. Now the slope of the line is M, which is equal to -1 upon MOP, because these two lines are perpendicular. So we get -1 upon tan alpha, that is, we can write this as minus cos alpha upon sine alpha or minus cot alpha. Now we know the slope of the line and we know the point through which it passes. Therefore, the required line passes through P cos alpha P sine alpha and has the slope minus cos alpha by sine alpha. Therefore, its equation is y minus P sine alpha is equal to minus cos alpha by sine alpha x minus P cos alpha. So this implies, now you multiply with sine alpha throughout, y sine alpha. Then I'm bringing the sine alpha here. I get y sine alpha into P sine square alpha is equal to minus x cos alpha plus P cos square alpha. Bring this x to this side, we get x cos alpha plus y sine alpha. Bring this p to the other side, p sine square alpha plus p cos square alpha. So this on the right hand side, we can take p common. So we get x cos alpha plus y sine alpha.
is equal to P.
So what did we do? See, only concept, pure concept. It is not that I remember the derivation step by step. And it is just logical concept. This is the point P. What is given to us? That this is a line whose normal makes, whose distance from the origin to the line is P, and the normal makes an angle alpha. So we should understand this alpha is not the inclination of the line, but of the inclination of the perpendicular. Okay. So this is x cos alpha plus y sine alpha equal to P. This is the normal form of the straight line. Now the normal form keeps changing as alpha changes. So let us see this. P, remember, P being distance is always positive. All right. Depending on alpha, the line can lie in any of the quadrants. As follows. So look at this. This one line, this is another. This is another. There's another. Now look at the perpendiculars. So these are all four perpendiculars. But look at the angles that these perpendiculars make. Here, this is alpha. This is alpha. This is alpha. Or, okay, we are maintaining that clockwise sense. This is alpha. This length is P. This is O, P. O, length is small p. O, P, length is small p. O, P, length is small p. Okay. So here, alpha lies from 0 alpha lies from 0 to 90 degrees. Here alpha lies from 90 degrees to, this is an obtuse angle. Alpha lies from 90 degrees to 180 degrees.
180 degrees.
Okay. So what will happen? Here cos alpha, cos sin alpha will be positive.
Yes.
Here cos alpha is negative,
Sin alpha is positive.
sin alpha is positive. Now here alpha lies between 180 degrees and 270 degrees. Cos alpha is negative, sin alpha is also
Sin
negative.
alpha is also negative.
Okay. And here, this is alpha lies between 270 and 360. So cos alpha is positive,
Positive.
sin
Sin
alpha.
alpha is negative.
Okay. Now you look at this. Look at this equation. X cos alpha plus y sin alpha is equal to P. I will write this in intercept form. I divide by P on both sides. Then I will write this by X upon A, P upon cos alpha plus Y upon P upon sin alpha is equal to 1. So this is your intercepts. So the line intersects the x-axis at, say, a p upon cos alpha comma 0 or p secant alpha comma 0, and the y-axis at b 0 comma p upon sin alpha 0 upon 0 comma p upon sin alpha. So you see now, so a is p upon cos alpha, b is p upon sin alpha. So you see here these points, this is p upon sin alpha comma 0, p upon cos alpha, sorry, x intercept, p upon cos alpha. This is a, and this is 0 comma p upon sin alpha. This is the point B. So here you see sin alpha, cos alpha, both are positive, and P is always positive because P represents distance. P represents distance. So P by cos alpha positive. So we see it, A is in the positive x-axis. This point B is in positive x-axis. Now here, this is B, 0 comma P upon sin alpha. And this is A, P cos alpha, P upon cos alpha, comma 0. Okay. So P upon cos alpha, P upon cos alpha, comma 0. So here cos alpha is negative. So P upon cos alpha will be negative. So that's why A is on the negative quadrant. But sin alpha is positive. So P upon sin alpha is positive. So on the positive quadrant. Understood? Now both cos alpha and sin alpha here, both are negative. So A A P upon cos alpha, comma 0. Sin alpha is negative, cos alpha is positive. Okay. So this is how, these are some very important features of the normal or perpendicular form. So next class, we will continue the other forms. Okay. Thank you. We'll stop here for now.
Thank you.